Hi, good afternoon and welcome to the Commit Happy Hour, unusually on a Wednesday as opposed to a Friday. Today's title is The Cost of Accuracy and Drones. And in just a moment, Tony will take you through and introduce today's team. We normally meet on a Friday and we usually have a friendly chat over a hot topic. There's no exception apart from this Wednesday today. So without further ado, I will now pass you to Tony and I will see you at the end. And one thing I will say is if you've got any questions during the session, please do send them in through the chat box and we'll do our best to answer them. So Tony, over to you.
Hello everybody and welcome to today's session. For those of you who are new to the Commit to Drones group, please do check out our website committodrones.com. That's COMIT, the number 2 drones.com. There you'll find our members list containing infrastructure, asset owners, construction companies, software vendors, insurance, drone companies, and of course lawyers. The key purpose of our group is collaboration. We collaborate to achieve individual members' goals in relation to drones within construction and infrastructure sector. Wherever those members may be on their drone journey, the group is there for them. One of the methods that we use to achieve these projects, these are always generated by the members. A member will come to Commit and say, this is a barrier to my operations. Can the group address this? And invariably, given the strength of the group, we can. And that is how the Cost of Accuracy project began. Today, we're going to take you on a journey from that initial problem through to the drone flight test and the conclusion from the gathered data. I will introduce you to the panel and then we'll have a short presentation followed by a Q&A session. We'd love to hear from you, so please do get involved. Please put all your questions in the text box and we'll get through as many as we possibly can. So without further ado, I'd like to introduce our first panelist, Mark Lawton, Chief Surveyor of Skanska, who originally got this project off the mark. Mark, can you give us an insight into what you were thinking in regards to why cost versus accuracy?
Well, hello everyone. Well, number one, a couple of years ago, there was a massive difference in price of drones and there wasn't the drones around that we've got today. So some of the drones there were a big separation in the price, £30,000 to £12,000. And in my field of work, earthworks, I only need 30mm accuracy. And other people need better accuracy. So why should I go and spend a lot of money on something that achieves my purpose, not the ultimate accuracy, but my purpose? So we needed to be able to establish that. And then there was a lot of other things that came out of it as well. But that was a general starting point. That's
brilliant, Mark, thanks. So that kind of kicked the project off. So that gives us the why. So our next panelist is Ian Billington, Consultant Innovation Project Manager for National Highways. Ian, you generously funded the project, you provided the test area at Morton in the Marsh. What interests a major asset owner in this project in particular?
Can I just double check that you can? There we go. Yes. So, from a national highways perspective, to move forward with drones and to start writing the governance and guidance around survey data capture using drones, we wanted to understand the reality of where we are today with levels of accuracy compared to cost of drones, and whether we could set a baseline to say, well, these are the minimum requirements that we would need to get the accuracy that we need going forward.
Brilliant, thanks Ian, appreciate that. I'm delighted to also introduce Andy Gibbons. He's the applications specialist geo-positioning Topcon Europe. Andy, you provided the ground control points that we use to benchmark the aerial surveys. How does this project kind of help an organisation like yours in surveying?
Yeah, good afternoon, everyone. Really, it goes towards putting the myth to bed that you need to spend or invest, as Mark mentioned, a high amount of money in the more expensive systems to achieve the greater accuracy, where in reality you can buy the lowest systems and get your workflows right, you can achieve equal accuracy.
That's interesting. I'll be looking forward to seeing that in what our next panelist who's actually going to be presenting for us, James Locke, Associate Consultant at Arcadis IBI. James, your company analysed the data and wrote the report and went above and beyond the brief that we gave you, and you're going to present in the moment. But if you could just give me, allow me just a moment, but before you do that, I'd just like to thank those members who we're indebted to, who gave their time freely to fly multiple drone platforms on the test site. Companies like Buckingham, Hexicam, Hollis, iRed, Plowman Craven and Skanska. I'd just like to say a big thank you, because without the panelists that are on today and all those members that were involved with flying and all those that gave their knowledge and experience free of charge, I just want to say thank you, because that is the power of the group, isn't it? Is that we all come together, we collaborate, and we knock down the barriers. So James, I'm going to stop droning on, and I'm going to hand over you for the presentation, and you can take us through the why, how, what, and where, and how we draw the conclusions from it. So I'll hand over to you, James. Thank you.
Indeed. Thanks, Tony. Yeah, just bear with me. I'll get my screen up. I believe everyone can see that now.
Yeah, we're good.
Yeah, just to confirm the commitments. Thank you. Okay. Yeah, I just want to talk you through, as I say, the kind of scope of this project and what we maybe did or did not conclude, which is maybe quite interesting. So fundamentally, as sort of alluded to there by our introductions, this was driven out of the understanding that obviously the drone industry is kind of exploding into other markets. Its use cases have expanded rapidly in recent times. And the key thing we noted was that the accessibility to it was very low. Increasingly, it's very easy for suppliers to acquire drone and sensor equipment, go through some appropriate, there are some stringent regulations around safety. But in terms of the kind of lowest bar, simplest use cases and so on, they're not particularly challenging for an organization to basically qualify and then declare itself a drone survey provider. So this was causing a market condition where basically you had lots of suppliers, but they might have a variety of expertise and obviously different quality that they were able to provide, depending on their level of experience, what equipment they were using, and so on. So the question here became kind of filling a gap of a customer's understanding. When you're commissioning a drone survey, lots of industry members, so it could be obviously transportation, energy, facilities management, construction, whatever it may be. You have these large sectors where project managers are understanding the benefits of drones and looking to commission drone surveys, but they might not be experts on the technology itself. So they probably have limited understanding of what they should and shouldn't be choosing, particularly regarding the hardware, the platforms and sensors, and then your data products. So there's this knowledge gap around that, and it's difficult to bring yourself up to speed, particularly as well in the absence of standards. Again, there are regulatory standards that define your safety and legislative requirements, but there's not a lot of guidance on exactly what is appropriate for a use case, what levels of equipment can provide what. So I'd say the entire kind of focus of this project was to really ask a question, and it's this question around what is the accuracy of the data product you can achieve in relation to the cost of your system. That is the sensor and the platform, the hardware bit that you're buying off the shelf. Because getting some understanding of that and the potentially complex relationship between the two is maybe the first step in providing some information for customers to commission drone surveys more effectively. So we went ahead and we undertook this study. As Tony mentioned, we had a number of participants from the Commit to Drones community, so industry providers of drone surveys. These ranged a little bit. You had some very major providers, some smaller ones, but all pleased to be there and obviously contribute. And we basically defined this test area. It was undertaken at the National Highways Motorway Development Centre, which Ian Billington kindly sort of put on offer for us and said we could use that space. So they have an area here that basically simulates a piece of highways motorway. And then there are a variety of other features. So there's some small buildings, some technology. There are some obviously soft features like trees and bushes and grassland and such. So we thought this was an appropriate area with some representative features of, the real world kind of thing that might be surveyed in association with, highways project, construction project, or related industries, energy and services and such. So we really defined this area, and then the idea was for participants to fly their systems over the area and capture aerial photography, just color imagery, no extremely complicated or nuanced sensors, so something that you can understand with the naked eye. And they basically capture this imagery. Obviously, it was taken away and processed, and the key thing is it was spatially referenced. So we provided ground control for them to orientate this and provide accurate outcomes in the real world. And then as a result, the data was analyzed to see how accurate they did achieve it in truth across a wide selection of test points. So really, we provided them some reference points to orientate it, and we held some back to say, to mark their work by, essentially. That was our metric for the test. And this was done in both axes. So we did a sort of lateral XY, a planar, and then we also did some analysis of the height analysis, so what results they were providing on verticality. So as we say, there are a variety of participants. There was originally scope for 16 systems. This quickly became apparent that not everybody could attend ultimately, not all equipment was available on the same date, and we weren't able to fit everyone in on a single day ultimately. So at the end of the day, we flew these systems here. There were 9, and we provided data from 7 ultimately. There are a couple of minor issues, which again speaks to how drone surveys can't be rushed, shall we say. There were a few things that we had to deal with, particularly the inclement weather. So ultimately, we had these systems of platform sensor pairings. So you have a series of very common, these are some of the most popular, well-known drone platforms here, ranging in price. And obviously, you have sensors to go with them. Often these are associated or integrated, though some of them are flexible, and you have a bit of a plug-and-play option with some. And you can see they come across a range of price bands. So you've sort of got low, medium, and high cost. We broke this down into ranging from about 1,300 quid there right up to 25,000 plus. So significant jump depending on what you're looking for. Now, again, this brings it back to kind of the expectation. I think this was the focus. This was asking this key question, and it's riding against this intuition that more expensive, higher specification equipment will automatically provide more accurate data. Obviously, that's the intuitive understanding, and I will fully support the idea that your equipment is what provides the ceiling on your ability. So at the end of the day, you're never going to get extremely accurate data out of some low specification equipment. Simply not that capable, because the fundamental positioning and the image resolution and such are the expensive bits, really. Having very high quality sensors, very, very high resolution, and having very, very expensive imaging, positioning software and such to orientate and update the position of the equipment is what then allows you to define your data position more accurately. So you see here what we're thinking of. Just to clarify, this is definitely a mock-up. This is not real data. It's just a general intuition of what you might expect to see. Obviously, as you go through the bands, you have a little bit of variety, but you get better and higher data accuracy data as you go into the more expensive bands. Preemptively, I confess we did have an anticipation that this might occur, and what you'll find is this really wasn't the whole story. And I think that's the message we're playing back here, is that looking at some of the results provided, this case study at least did not support that intuitive expectation. What you see is this kind of more cluttered scatter of results that are more homogeneous and less defined across those price bands. I want to point that none of these were terrible by any measure. All of these were well within expected kind of boundings for a variety of appropriate use cases. But there comes the real question is, when your use case varies, you're going to look at different systems. So to go into a bit more detail here, you can see this was an accurate spread, and fundamentally what we proved was, in this case at least, one of your sort of second or third most expensive systems from left to right, your DJI M300 it was in this case, in pink there. For the XY data, that was by far your most accurate. it's got a very, very good quality result. Again, you had quite a lot of homogeneous results from the rest, and then one of the cheaper systems you could see had some strong outliers. So that Phantom 4 in the purple wasn't necessarily great at this test site. However, we flip over to the Z accuracy. I appreciate this is slightly harder to interpret. We basically broke down the types of features you see into hard, soft, and very soft. This reflects just the reality that if you're scanning downwards on something like concrete or asphalt, you're going to get a very good, solid result. If you're looking at grass or worse, bushes, shrubbery, and trees that have leaves, different levels, and move in the wind and such, you're simply not going to get an accurate return. So it's kind of expected to be a worse return on those. But here again, you can see from left to right on each of these diagrams, there's a spread. And interesting in this case, the previous system that performed so well on the planar analysis had such strong erratic outliers, we've actually excluded it from this graphic because it's through the distribution. And one of the less expensive systems we see, again, the Phantom 4 there that performed perhaps poorly on the previous test, showed very good Z delta results. So you're seeing this kind of composite idea that different systems might perform better at different circumstances, at different target features and so on, depending on the type of work and the layout you're doing. Now, obviously, it's hard for us to conclusively say exactly what was the cause of this because there's a lot going on here. Apologies. Confirm, can you still hear me there?
Yes.
Sorry, I think my headset just disconnected briefly.
We got you.
Good, thank you. Yeah, just going on from that, what we kind of observe from this is obviously the flat cost of your system and your sensor aren't the be all and end all here. And observationally, we can say there's a lot going on outside of that. So you have a variety of factors that influence, the quality of your outcome in your flight. Being typically British, of course, we're very concerned with the weather and things like your aspect, your lighting, and your weather, even moment to moment. So shifts in lighting and shadow, and shifts in things like wind speed and so on, or moisture that can affect your flying conditions. If your aircraft is experiencing a lot of different, brightness or quality of resolution, basically based on murky imagery, that affects your accuracy. Equally, if it's experiencing changes in speed, being buffeted and vibrating and so on, that can affect your positioning. So these are no doubt significant factors. In fact, to say those were some of the factors that were cited as basically preventing two of the systems submitting suitable data. One of the more expensive, higher quality systems, on examination, the data found there was simply too much turbulence that was encountered. And I don't fault the provider or the system for that. It was, unfortunately, intermittently a very breezy day on which we did this. So we're kind of hedging our bets that some of this data would come out at the level desired. So that kind of proves that there is some constraint in that respect. And it's not a perfect science of saying we're going to do this survey at this time. There's some flexibility and understanding that you really do have to sometimes wait for appropriate conditions, and you might have to plot out, projects based on, a timeline with windows where this kind of thing can be undertaken. Further to that, you've got things like ground control. So as we say, we provided ground control, but in a variety of independent tests that we undertook, we proved that you could adjust the way in which the ground control was used to basically improve or distort results. This was a relatively flat site, not that many high axis features, but basically if you have a lot of Z variance, so if you have steep topography, cuttings, or of course objects like buildings and so on, you need control to accommodate both the lateral and the vertical model there to ensure that your various tie points can be orientated and provide accurate data across those differences. I think the kind of black box here, which is, I say, quite hard to quantify, but it's understood that there is a variety of data processing tools and techniques and different processing workflows that could be used. So exactly, the tools and software used at the back end are a consideration, and they're also kind of a risk and a hidden cost for those commissioning drone surveys. It's easy to understand up front what kind of hardware you're getting. That's very answerable. You say, look, this is the kit. We're using this specification of platform and sensor, and that gives you some confidence in the results you'll be receiving. But in terms of what's going on in terms of processing, it can vary significantly from provider to provider. And again, that can represent either cost simply based on the efficiency and the amount of bodies and expensive software you're throwing at it, and impact on the quality likewise. So I think having a clear understanding of quality control and standards to be met is obviously very key. I don't wish to teach anyone to suck eggs, but it's one of those things that needs to be considered and perhaps enshrined into some kind of contractual arrangement, that it's not simply we're going to commission this survey and you're going to provide whatever data. Having a quality benchmark in mind before the survey is delivered to basically validate the work is always worth having because of some of these variances. So I think largely that's the takeaway from this, is that there's a lot more to commissioning your drone survey than this, high price equals high quality. And given the breadth of the market, there's a lot of variety, and you can have some very high quality providers that are very efficient and have found the right tools and software and so on that suit them. Conversely, you could have some effective cowboys coming to the market with some very expensive, shiny looking kit, which is seductive, particularly for people who don't really understand the nuance of this technology. But you can see how that doesn't always equate to the best quality result. So it always brings us back to this kind of focus point, which is, what quality of data is required before commissioning a survey. It's useful to understand the precision that's necessary for your use case, be that a single use case or a flexible data set that you might want to retain and serve multiple use cases. So there are decisions there of how efficient it is to get more quality today on the assumption you can answer more questions down the road, whether it's a single kind of one and done scenario where, provided the individual application doesn't require extreme quality, you could get away with something kind of cheap and cheerful that's more efficient. I think the upshot of all of this is obviously the intention here was to kind of pose that question and shine some light on it. I do regret that there aren't some very conclusive answers there. I appreciate this is somewhat of an open box now, but I think that's part of the point here, is to lay out this narrative. Commit to Drones can support the drone community and all of these drone commissioners, basically helping them understand with case studies like this that you can publicize and say this body of evidence that can be built up will help inform the decisions you make and give you something to turn to and say, okay, what studies have been done, what information is available, how can I quickly and accessibly clue myself up on the right kind of knowledge to cut through a lot of the technical detail that might be extraneous to them, but to understand some of those fundamental considerations and decision points. So yeah, I think I'll conclude just obviously ultimately, if you wish to better understand, I think more work could be done. Recommendations included a more kind of exam question based trial. So as opposed to looking at sensors and platforms in the breadth and saying which of these performs best for its cost, you could invert it and say, well, I have a requirement to get 30mm accuracy for a hypothetical project. Which of these systems or providers can provide me that fastest or cheapest or most efficiently? That would be a way to kind of winnow it down, have a slightly snappier version of a kind of banding similar to what the RICS uses. They have some survey standards and guidance that do refer to things in this manner and provide you more of a kind of a guide band to say what you require for this kind of work is this kind of accuracy. So it's riding on the back of that and saying, well, these products at least have been validated to do so under test cases. But obviously up to Tony et al. To decide on future considerations there. So yeah, with that, I will wrap up. Thank you all.
Thanks, James. I think what we'll do is we'll get the panel up and we'll start looking at some of these questions that we've got coming through. So if we could have the panel. Hi, guys.
Okay, Tony, you should be able to see the questions now. No, if not, I can read them out.
No, I've got them. Okay, we've got the panel here. So we got some questions. It's Kevin from the Land and Drone Survey from Balfour Beatty. Were all the cameras settings the same for each drone? As I understand, the quality of the photos in GDS determine the accuracy. Anybody from the panel want to take that one? Do you want me to read
I can
it?
take that. I can say that they were not all the same. They were within the appropriate bounds. So we defined the area, the duration, and the height, as opposed to defining the camera settings. Obviously, depending on the systems used, they would have appropriate settings for things like field of view and such, and refresh rate to meet the timing and the flight plan requirements, as opposed to the other way around. Obviously, you could take on board that's a good point. You could reverse the study and do the opposite and say you've got a wider opportunity to fly freely, but we would constrain all of the camera settings. The decision was really, to some extent, we felt that would basically kind of kill off the point of having different sensor systems, because inherently the difference between the most expensive model and the cheapest model is built into those different settings accordingly.
And it was also down to how you use it and operate it for the majority of your time as well. So you find a banding where you would use your equipment and the settings, and that is generally your optimum normal working practice.
Brilliant. So I'm just were all the tests done with self-navigating program path drones, or were they controlled by a human? I think they were all controlled by humans, weren't they? There was no autonomous drones here.
No, sorry to challenge you on that, Tony. I believe it was the opposite. I think they were. You do manual takeoff and landing, and then you they programmed in. Yeah.
Yeah. That's why you don't get me to fly. So. Thanks, Ryan. How did you address battery life for the drone? Stop and start or swap batteries, or some version of automatic battery exchange?
So it was essentially, stopping and starting and swapping batteries. We did attempt to constrain the flying slots and basically, again, try and normalize as many variables as we could. There were one or two drones, again, some of the larger, more expensive ones, which had to stop multiple times and rinse through batteries. So we did note that was essentially breaking the intended time slot. They exceeded the given time, which is something you consider in terms of efficiency. Obviously, we didn't bake that into our analysis of cost. You'd have to attempt to kind of equate the speed of the survey to the cost of the service as a whole. But yeah, it's another variable that is worth considering, and definitely, with obviously the higher the quality and the more expensive the system platform, generally the two correlate. You're more likely to be taking longer to capture high quality data and then swapping out your batteries accordingly.
Mm. After data capture, did all the systems use the same software for analyzing, analysts stitching it together?
No,
they're all different.
Again, yeah, representative of the industry, and obviously all of these different participants, they would be using what they normally use day to day, and there is quite a substantial range. So in advance, we did get some understanding of the breadth of products used, but I'd say there's sort of maybe 10 plus possible options. Some of them are branded and bespoke to a different platform. Others are kind of more third party or open source. So
lovely. Thanks, Fran. That was all from Fran from the USA. So this one's from Seb from Plowman Craven. I think this one's directed to you, Andy. What was the accuracy of the control points, and what equipment was used to measure them?
So in this case, we used a 2-second total station, a couple of prism stations, run a Travis least squares adjustment, and then adjusted it onto OS, National Grid coordinates, to make the data easier to use.
Lovely. That's fantastic. Yeah, I'm just waiting for some more questions to come in. So Could I get from each of the panelists what we had this expectation at the beginning, and then we have the results at the end, and we have this gap between it. What were your thoughts about that? Can I start with you, Ian, as an asset owner?
Yeah, I mean, it was a bit of a surprise, really, not quite as we expected, and it has opened up a number of questions around how do we set that standard for guaranteeing the level of accuracy for survey standards going forward, and if we can do that. There's obviously all those parameters around weather, pilot experience, and all of that kind of thing, but it's how do we move forward to try and set some kind of requirements and standards around the data capture to set those levels of accuracy to whatever we require going forward.
And Mark, what were your thoughts? So what we're looking for there is some type of standardization. Some people call it the aerial surveying, the black arts, I've heard it referred to. A lot of construction companies are coming back to me and saying things like, the data that drones are providing aren't very good. They probably pay a low cost for it. How do you differentiate between somebody who is good and somebody who is bad? How do we get over this high variability in the industry?
So there's a number of things to unpick there. So let's start with the control. I think that anyone coming delivering a survey needs to deliver a survey control report. And what Andy just alluded to is he named the second of an instrument and the method. He didn't go GPS first, he went optical, localized it, and then moved it to grid. So applied the precision. If you have got that there as a standard, and remember that one of the problems they have is when people put in control, it isn't permanent control. So you can have a survey, and then you pull your ground control points up, and there's nothing to refer to. You can't mark out what you've just collected in the future. So you've got to have that link. You've got to have a survey control report that shows legacy control done in an appropriate manner, and that's why Palmer and Craven asked that. And then you've got to understand the purpose. So I'm not going to use my type of drone to do survey work to find to do tarmac, because I know it's 30 millimeter inaccurate, and the wearing course is no good. Because I work in heavy civils, and 30 millimeter accuracy is suitable. By the time I push it up to the cloud, what we do now, and get the data back, I expect my bulldozer to have put in this much material anyway. So the 30 millimeters is fairly inaccurate for the work that I do in the precision part. So if you understand your precision v accuracy and your application, then you can choose the product that's valued to you. Would I go and buy the most expensive drone to do this work and the most expensive process? No, I wouldn't. But if I was doing a topographic survey to start a design, I would use a different method and different tool sets to what I've currently got in my fleet.
Excellent. Thanks, Mark. That's very good points there. James, somebody's actually agreed with you on a point, so quite happy. This is, forgive me, is Indica from BBV HS2. He's done about 12 case studies taking survey data and P4 RTK drone. I agree, James, what's said. Even without GPS, I achieved 25 accuracy using my workflow only checkpoints. Can you expand about that? Because people like myself not sure what.
Yeah. So again, this is alluding back to the the nuance in using different layouts you control or different processing workflows. Basically, with shall we say, a less advanced system, you can still get good results if you're confident in your techniques. And again, of the target and of the requirement, going back to what Mark just said, perhaps it's drifting from the original question a touch, but the only way to fill this gap is knowledge and experience. That would be my takeaway. And obviously, Mark's explaining there, and so is our questioner, that having some understanding of the tools that you've used previously, having a little bit of that experience under your belt and knowledge of the elements in play here. So again, I don't expect anyone to be a drone expert if they're just commissioning surveys, but having a rough understanding of the various variables, not just seeing the presentation of this is expensive equipment, therefore it's good because the numbers on the spreadsheet say it's incredible accuracy. Knowing that there's a lack of confidence in that to some degree, and combining that with a bit of experience, saying, well, we know that different results can be achieved for different targets. That's really where it comes together. So yeah, I think the most valuable thing here is the knowledge outcome, and obviously future materials to further support that.
Oh, lovely. I've got a question here for the whole panel. Feel free to anybody who wants to do this. This is from Rory Giles from Shetland Flyer. He says a lot of operators are placing reliance on drone RTK positioning without any GCPs, ground control points, using a single site base. What is the panel's view on this? He personally feels RTK is very useful, but not without ground control point checkpoints. Anybody want to come in on that? I think it's a great question.
So it depends what you're doing. If you're doing a landfill site and you're doing a tip, then there's a purpose. If I'm doing a stockpile, which is a shape that I don't really matter about the drift, and if the stockpile is up because it's a shape and a lump, then fair play. But when you're starting to blend other things in, you want them to be in the right place, as Indigo said, is that you're going to start to need a minimum of 5 points to bring down the center as well. So you've got to think of the purpose of really what you're trying to achieve.
So work yourself backwards from it. So what is your accuracy, and all the way forward through that. So again, I'm just waiting for a few more questions. So I would say to all our delegates out there, if you could throw your questions in, I'm sure you have loads of them. Please.
If I could add something, Tony, there's something that was overlooked. All the sensors that were on the for the accuracy study was just looking down. So some of the aircraft that are out there, when they're different payloads, you can't just judge the aircraft that you're going to use because of this report. Because if you're looking up or looking sideways or doing different things, you need a different aircraft for that as well. So we have media grade and survey grade equipment. And if we're just going to do a video, rough RTK for taking photographs, it's good enough because it serves the purpose. So you do end up having a mixture of fleets.
No, I quite agree. And I think that adds the question, doesn't it, is that we've done this survey. We found out that there's not really a correlation between the cost of the equipment against the accuracy. So, we were trying to find some type of some consistency within drone aerial surveying. Where do we go now? I mean, is that too early a question to ask at this stage of the meeting, or can we, should we be looking to address that? We've done this. It didn't come out as we thought we did. Where do we go now? Maybe we could go across the panel for each one of you. Who would like to start?
I can say that again. I suppose I'm sort of reiterating on my closing statements. There is understanding your needs are where you need to begin, as opposed to understanding the capabilities. And I think reverse engineering exactly what your question and your use case is from the systems available will immediately set a benchmark, at least in terms of cost, for your minimum. Because if you need extremely high accuracy, engineering kind of grade measurements or whatever they may be, we know that the least expensive systems won't be able to meet that because it's simply below their on paper specification. So that's your first guide point, is to say, well, we know which systems we can preclude, and you can basically do a lowest cost analysis there, really going as low as you need to meet your minimum standard. From that, you then have to move into the space of understanding that the equipment you've selected has the potential to meet your need, but it won't de facto meet your need. The result has to be validated against the need before it's considered delivered. Now, perhaps that will drive a form of cost increase and kind of an insurance in the industry of sorts, where basically instead of saying, yeah, we can provide this at this level, here's the cost, there you go, that validation step puts risk onto the side of the the drone supplier. But fundamentally, it's necessary for major organizations to have their data validated to the quality that they request. So it's really putting the power with those who are commissioning surveys. I think that's kind of your route. It's more knowledge and information for those people to make informed decisions, but ultimately it's standards guidance and ultimately contractual elements that I think will help ensure that you are getting the quality you intend from the providers you've commissioned.
I think that's a great point. You also have to look at it from the drone provider's point of view as well. Those guys that are providing, and majority of our members, well, all of our members are providing great quality data, are being undermined by those drone providers who don't have the necessary skill sets and are charging a lot less. And we get a problem within the industry because it knocks confidence in those that are buying it, like from yourself, Ian, because there's no consistency, or Mark, with your in-house drone teams against, should we go out to outsource it, in terms of that. How do we get some surety into the market? I mean, is it another project where we look at trying to do, by activity, or is it some other variable that we can bring some consistency and standards into it? And I address this out to everybody who's viewing as well. Do you have any ideas how we can actually help asset owners, construction companies, in-house drone teams, and drone providers? Because half their time, 3/4 of it, is actually talking about and educating the person that's commissioning it and trying to justify it, why somebody who's done 4 weddings and a funeral and has got a commodity software package is as good as somebody who's got lots of experience and who's charging. Do you kind of understand the question? Where do we go next?
To reiterate James's point, is that by having a report that is written and read by an expert, if I was going out for precision, for ultimate precision, I would probably use a subcontractor, because they're going to use different tool sets. I'd measure them, different tool sets, different software and different processes, rather than my in-house team. My in-house team does a particular task, where I would expect a report, a verification of that report, and some type of check measures. Now, someone that is going to receive a report is probably not going to understand a lot of the technical jargon in there, but will know to look for the comparison, and they can send any engineer out to say, these were the comparison report points, pick half a dozen of these and do another check. That's what is done with all surveys, regardless of the capture method. A road tie-in, you go and check it with a GPS or a total station or whatever tool you're using, but you'll do a check. So I'd advocate, ensure that you get a survey control report with the drone survey, and if someone doesn't do it, then just walk away from them and pick a company that does, and then check their verification points.
Is there anything as a group to kind of like take it forward to the next step?
It's difficult, Tony, isn't it? Because the industry is changing so fast. I mean, you can look at things like cloud densities and the speed of turnaround from photogrammetry. There are other things that have been measured. So you could, if you picked a device or a category of price of devices, say, look, this is the ultimate pricing of a drone between, say, £4,000 and £8,000. This is the market. But now, what is the turnaround time and speed of actually, once you've done the flight, how is it processed with limited contact to that processing? Now, before everybody snaps their head off, is that you must check your control before you push it up to the cloud to do the automation. But if we're looking for efficiency, then you might be measuring the turnaround time of cloud processing.
Oh, brilliant. No, thank you. I would like to, if we can, actually get some of the audience on camera and give their comments and views if that's possible. Stuart, can we do that?
Yeah, absolutely.
Yeah.
Anybody with a hand, but if they want to put their hand up, they can. You know, there's another 5 questions come in, Tony. I don't know where you can see them, but
yeah, I can. Could you get us up, Rory, because he's got a quite good point.
Yeah, Rory, we can bring you in if you're available. Rory, where are you?
Rory Giles.
There he is. Yeah. Okay. Rory, if you want to come in, you're very welcome. Open your microphone and your camera.
Yeah, can you, oh, sorry, wrong camera. Give me a wee second.
We can see an image.
Yeah, sorry, it's doing something funny. Can you hear me okay?
Yes.
Yeah, okay. Just one of the comments I was really going to make, it's really more a comment on what was being said there, was I fully agree with Tony with what he was saying. That what we find is there are a lot of so-called drone surveyors that are rocking up with a Phantom 4 RTK or even an M300, something like that. And then they do the flight without really any consideration to satellite conditions. They do the flight without any consideration to lighting conditions, which is incredibly important. They go back to their office, they chuck it into Drone Deploy or Pix4D or one of these cloud services, and then just deliver services, and then just deliver what comes out at the other end. As Mark was commenting, okay, that's possibly fine for a stockpile survey if you want to measure the volume of a stockpile, but if you're doing something that's happy to tie in, I mean, we do a survey for BAM every month for a rock face, which has got a bund behind it, which is at quite an angle. It's about 40 degree bund. We're detecting for any motion in that. So the accuracy of that has to, we're trying to achieve, like literally better than 5 centimeter accuracy, so we can actually compare the clouds together and check that these things are not moving at all. But if you get any issues with that, even if the satellite conditions are not right and we're using control points, you're still going to get variance, and this is what we're finding. So we're aiming for 50 millimeter accuracy, but generally it's coming up to 50 millimeter. But I saw some stuff that an operator had done down in Orkney. I helped. I saved them actually. They sent this stuff up, and they put their stockpiles through. They measured the volumes using WGS84. So they're working with ellipsoidal heights. And to be honest, when I processed them for them, I was getting massive differences in the volumes. Like between, instead of sort of 3,500 cubic meters, it was going down to I was getting just over 1,500 cubic meters. So that's half the volume. But I just using WGS84. I really feel there needs to be some kind of standardization across. So this is probably from our side, from the drone industry, from the service provider side, and maybe some form of, I mean, a lot of these, I have a surveying background, so I'm okay, but a lot of these guys are doing good work, but they're not producing accurate results, and it's giving us a bad name. It really worries me. Just kind of be interested to hear any comments on that, and if any of you guys have kind of experienced that sort of.
I mean, Ian, that's something you're going down, isn't it? Looking at standards within national highways.
Yes. So going beyond where we are, we just kind of the standard survey guide now, and expanding on that to include drone specific data capture if possible. Again, this report has shown that there's still some work to be done to be able to standardize that.
So Rory, I think what we'll do is we would like your ideas, so throw them over and see, challenge the group into creating standards.
Yeah, I'd certainly be up for that. I mean, we work a lot quite closely with RPAS, which is and they've gone down more the compliance route and stuff like that. But it was a very useful platform a couple of years ago for looking at CPD and looking at standardisation. But that seems to have slipped from the remit a wee bit, which is a shame. I mean, if anybody doesn't know, RPAS is it's basically a trade association for drone operators from all levels, from tiny companies up to like large companies which have possibly a drone department within them. But yeah, I would certainly be interested in throwing some of my ideas over to you if you would be keen.
Oh, we're very keen. I think it's one of the big barriers.
Tony, if I was procuring a survey, first of all, I'll make sure that the members of a professional institution, be RICS, CICS, TSA, because they'll have that background there, and that professionalism comes with it. So people that operate professionally normally have to go through some level of verification of their capabilities to be that membership. So that's one area where an uneducated client in technical capability can entrust that person that's got that membership has possibly got the skills that are needed to do that. Not always, because they may have come from a separate route, but it's a level of protection that those that don't know could use. It doesn't protect you fully.
Well, thanks, Rory. I really appreciate your input there. And like I say, we'll try and work forward on that.
Before I mute myself again, this has been very interesting and very useful. And I just like to sort of, rather than typing it down, it's like, I think you're talking about the various platforms, and unfortunately I couldn't make it down to that. It looked a very interesting event that you had back then. But it's I mean, we have various platforms for various tasks. So the Phantom 4 RTK still gets a lot of outing because it's a fantastic drone for stockpile surveys for the sites we're doing at the size of one of the sites we work on. It's perfect for that. We've got the Matrice that we use for thermal surveys because it carries the thermal payload, and then we've got the SenseFly EB that we use for larger areas. So there's not a one size fits all. The M300 is possibly getting there because it's very good at doing large areas, but then you're hit. Another comment is you're hit with the ceiling. We've got a 600-foot exemption from the Civil Aviation Authority, so we can fly at 600 foot to cover larger areas at lower ground sampling, higher ground sampling distances. But yeah, there really is not one size fits all. Is my experience, certainly.
No, I think you make a good point there, Rory. Yeah, thank you very much. Really appreciate that. Stuart, can we get Graham Keeneler on?
Yeah. Graham, if you're willing to come in, I will promote you and open your mic, open your camera.
You there, Graham?
He is, yeah, there he is.
Oh, it's unmuted. Can you hear me okay, guys?
Yeah, we can. Yeah, go ahead. I see your question in the thing. I think it's a very good one. Do you want to expand upon it?
Yes. So I'm not a drone expert, but people within our company are. And I was speaking to a colleague who's in Singapore. He was explaining that there's legislation now within Singapore that building owners over a certain height have to have the facades periodically inspected, and so there's a big activity to achieve that. And obviously then that idea, which we're talking about now, the stabilization, and then so at the beginning of next year there will be a certification that's for drone certification. to be able to provide AI level accuracy and in crack detection, plaster, concrete and spalling, etc. So I just wondered if there are lessons that could be learned outside of the UK, maybe markets that have been driven to be for a journey.
Yes, sorry, Graham, you're cutting out a bit there, but I think we can kind of get the gist of it. Is that in Singapore they've got some standard inspection certification going on. Is that correct?
That's right. Yeah, and they're moving towards a service providers certificate beginning of 2023.
Okay. Do you have any information on that?
I could seek some for you and forward it on retrospectively, Tony, if you wish.
Yeah, that'd be lovely. It's always good to see what other countries are doing. Yeah, and I mean,
Tony, I think the thing to jump on that jumped out at me is the AI crack detection, which I think is prudent to everyone on this panel. That is a really good way of reducing working at height by using drones and crack detection. So I'm sure there's a question in there for the panel. I know that it's prudent to the majority of the panel. So let me ask a question for you. Is that using inspection and everything, where do you think, if this legislation came into the UK for facade detection and crack detection, how could drones in the UK help solve that? And what should we be thinking about to ensure that we're getting good data from crack detection inspection?
And is that a question back to me?
No, that's to the panel, to my friends, because I think it's a good question that you posed.
After that question, you've got no friends. So
I think you're kind of raising the same challenge, which is that to provide any industry standard on these things, they have to be outcome driven. So it's, in a competitive market with changing providers, changing equipment, changing techniques and so on, and a range of these, you can't really legislate and say you must use this equipment for this thing. It's never really going to happen. So for repeatable, standardized, high priority tasks, you could potentially form a certification process as described in Singapore there. That might make sense for some very broad and also kind of unchanging use cases as well, some things that you can pass into established practice and make standard. So crack detection is likely one of those. It might still take a couple of years to get through this transitional period, but perhaps you could. I think sort of just reflecting on the bigger picture, the challenge here is there are so many drone use cases that are being considered or already in progress, and even the same use case can be used for different scales of application or different environments. So again, even standardizing the outcome, or at least a certification process, is very challenging to enshrine into a set of kind of auditable process and say, yeah, if you do all of these things, you'll always get the result. It still kind of exists in the advisory and understanding place, I think.
But it would be good to have a look at that Singapore, wouldn't it? Yeah, Graham, we would welcome that information. And if you want to, get in contact with us, we can have further discussions on it. Would be really interested in it.
Yeah, well, certainly will, Tony. And I know at the moment our R&D division in our company are actually working on that AI aspect of it right now.
Brilliant. No, I look forward to that, Graham. Thank you very much. Okay, it was a great point. Can we go to Fran, Stuart, and then we'll go to Steve Crossland after that? Stuart?
Yeah, sorry, Tony. I was on mute. I've just invited Fran. Fran, you should have a notification. Unmute and on mic. Oh, sorry, both the same. On camera. Fran, are you there? There he is. No.
Okay. Can we go to Steve Crossland then, please?
Yep. Can you hear me?
All right. Hi, Fran. Hi. We're kind of running out of time, Fran. I know you got lots of questions.
Yeah, lots of questions. Well, one thing, Tony, that I'll follow up with you later
Yeah.
working with Stuart and another group on 5G, which is communication in general. And
Yeah.
I know, drones today use a variety of different technologies for wireless transmission. So I'll also send you a pretty good white paper that talks about a lot of options and things like that. But first of all, congratulations to the group on doing this. I think it's important. On the batteries, I mentioned about that. You might want to look into, and I've talked about them before, companies that will allow you to automatically do battery changing. So then you program it to do a certain path, and as long as the laws and things line of sight don't come into play, you can cover a wide area automatically. So I think the emphasis going forward by drone operators is going to be speed and areas they can cover in an amount of time. So that's important too. I also think there's a range of options for usage. For instance, if I want to do a disaster relief area, I really don't need lots of accuracy. I need to know that this area is really bad. This area, has people underwater, whatever. I need sort of quick visual capturing. So I think it's important too to at least address that somewhere along the line.
I think Mark has got a good analogy for that, is that he rates things from media grade all the way through to accuracy survey grade. That's right, isn't it, Mark?
Yeah, generally, yeah. You're taking a photograph and a video for briefing people on flying around, and then the survey grade is when you're actually good to make a DTM, essentially.
Yeah.
Yeah, and I think another sensor that's often overlooked is infrared. Infrared's great for, like, covering a fire area or, checking roofs and things like that. It seems like a lot of the focus on sensors has been on either use of photogrammetry or location, type things. Anyway, those are my couple of comments. I'll send you a paper later, Tony. You can share it with the other group, and I'll post it also on communications in general.
Yeah, just to pick up on some of your points, we, as a group, we do work with Ofcom on Signal, which is the UK regulatory signalling, looks at the spectrum. In terms of battery, we have a lot of members who look at the battery problem in terms of hydrogen. Also, they have automatic swap outs. So, Frank, happy to point you in their direction if you want to talk to somebody on that level.
Yeah, I'd also like to add some that I know or something, referring to you. They're not in the UK, but they cover worldwide. They're doing stuff at the border here. I'm not sure if it's doing any good. They're capturing these images automatically, but that's another issue. Anyway, yeah, I just wanted to add some of that information. Share. You guys are doing a great job, I think, in looking at these. And I think, the accuracy and, the usage and the use cases that you use are important, but I think we're going to come down to, sort of becoming an everyman's tool, that every facility manager will have some drone to go to check the roof, maybe to do occasional sentry security stuff, things like that. And I think those are important to cover too.
Yeah, no,
anyway, great job.
That's definitely the goal. And thank you, Fran. It's always good to get a perspective from over the pond. So anything you can bring from the US is gratefully received.
Well, over here, I think our biggest problem is the FAA and the rules and regulations and things like that.
We have Steve Crossland who joined us, Tony.
Okay, hi Steve, are you there?
I hopefully will be. Hello.
Hi Steve.
Can you hear me?
Yeah, good, thank you. Yeah.
All right.
Yeah. So,
okay.
Yeah. Do you wanna quickly talk about what your question you got here, or
Yeah, just in terms of the sort of the general panel discussion, is on sort of about the fact that in terms of standards, specification side of things, it really sort of ran parallels with, I think, where we were with specifying for utility surveys and the like, and it sounded very similar to what you're doing now, to be honest. So I think there's some parallels to be learnt potentially through this, because we had, I say in my question, we had a similar scenario regarding specifications of surveys for utilities, and from that we got PAS 128, yeah, which is basically provides quality levels of different types of surveys plus accuracies and things like that, which is something that we use not necessarily on every project we do, but it's definitely something that we cover. So is that something that could be considered in terms of what you're trying to achieve here, which I think it probably does need to be initially, I think, looked at to see how you can standardize. Certainly as a specifier, I'm not a drone operator or anything like that. How do I properly engage with, you know, all these great companies are out there? I don't know one drone from another, to be honest, and yet I'm wanting a specification to be given to those people to actually price it and understand the work. And that's what PAS 128 was all about. So for me, I think there is certainly lessons to be learned in this particular instance with drone survey type work as a question stroke observation.
So basically, we'll have a look at PAS 128 and the methodology that they're using. Does anybody on the panel know that, or sorry, it's not something in my skill set that I know. Mark, I know you do a lot of utilities in SCADA. Do you know PAS 1?
So PAS 128 for the detection and 256 for the verification and report. They were made. But I'm just on my other screen here, so I'm looking down. So there is some client guides that are out there on the TSA website of about small unmanned aircraft, but like they are client guides. I don't believe there's a PAS on that, a publicly available specification. And generally they're made under charity, so you'd need to get funding for that, for it to be pushed out. But I'm sure if we gain to this point that between the RICS, CICS, RASPAS, yourself, that people could come together to make a standard. But utilities is one particular thing. The application of use of drones is used for so many things. You'd end up with, I would say, bandings. Yeah, we do need it. Just going through my brain, yeah, we do need it. We need that adherence to ensure that when you're doing a stockpile or an asphalt survey or you're measuring a bridge, that you're doing it to a level of specifications just similar to what is in our ICS topographic survey bandings.
So is it something that we can take forward with? Is that'd be helpful? Is that what you're suggesting, Steve?
I think it is, because I say we sort of at that sort of crossroads a few years back with these sort of utility surveys. The TSA were involved as well and things like that. And it was how could we get that sort of an industry-wide guidance out there that everybody could reference and use, of which obviously PAS is able to do that. It's not a full British standard or anything like that, but yes, you're quite right, Mark. There is need to have some funding, and that funding was made available for the PAS 128 and PAS 256. So I think there is probably some serious need to look at, if that is the way forward, is to how best we can look to get the BSI involved, and obviously look for some sponsorship for all that. Like I say, sponsorship, but certainly money's towards it. To be honest, to pay for that, it is relatively cheap and relatively quick to get a PAS through there. But I appreciate what Mark's saying there. It is a very complex situation in terms of what you are trying to survey and everything else there. But it's exactly the same similar scenario that we had with the utility side of things for me, in terms of the quality levels that we had to do and the detail that we had to go into. I think it's possible, put it that way.
No, I think it's a very good point. I think what we'll do is we'll circle back to you, if that's okay, after this, and explore it a little bit more, if that's okay. I just need to we just need to kind of like get ourselves up to date with it, because we've looked at BSI, and BSI just costs phenomenal amount of money.
It does, yeah, it does.
Unbelievable. We've talked to those guys. The first one's free. The first, then the bills come in. So yeah, thanks, Steve. That's a really good point. We will pursue that.
Okay, thanks.
Thank you. Just a quick one, because I know we've run out of time now. It's from Jonathan Robinson. He can't talk because he's in the location he is, but it's interesting how aerial surveying by default is assumed to be done by photogrammetry. Perhaps guidance specifications should be quantifiable, numerical, rather than specific technology. We have LiDAR customers that can quite happily produce low CM level surveys. Also, our equipment can be placed on drone platforms from 14K upwards to 60K. End results of payload will be broadly consistent, meaning the cost of accuracy matrix unlikely to fit. Finally, if a company chooses to invest in a high-grade sensor, doesn't mean they can't vary their tender prices to bid for a survey that is low and compared to their capacity of their kit. Interesting comments. Can't speak due to location. I think there's a couple of points there. One is why do we include LiDAR? I think I can answer that one. Is that photogrammetry is probably the most common at the moment, and that's the one that we kind of went for. LiDAR is catching up, but there's also other sensors out there, hyperspectral and multispectral sensors. So I hope that gets that little bit of the question. Anybody want to take up on any more of the question?
Oh, just going to add to that, Tony. Obviously, you're correct that there are different sensor options, and LiDAR is perhaps was the super high accuracy previously, was maybe somewhat superseded by the cost and efficiency of photogrammetry, is now getting cheaper, so coming back around. Obviously, we did constrain this study. I think something to note is we didn't consider that future of alternate sensors, or of course data fusion. So you can use LiDAR data to then orientate color RGB data, say. That itself is probably the way to get the best possible results across the board. But I'd hazard that there's a cost involved in processing that data, and there are probably other pitfalls in those kind of workflows. So again, it follows the same trend that you have to be sure that the industry is mature and that you're selecting competent providers for those services to get the best result from them. But yes, it's definitely something to pursue as this whole sector is continuing to mature, and different elements are coming back in and out of the mainstream.
Yeah, thanks, James. I think we've run out of time, as always with these things, as we're starting to get warmed up. What I'd like to do is just go quickly around the panel and get a conclusive remark from everybody. What is the next step? What are your thoughts? Those type of things. Can I start with you, Ian, and then work our way across? Thanks.
Yeah, so this is definitely something that we're looking into going forward, trying to set these standards and look into how we can set these levels of accuracy consistently with what we're doing going forward.
Thanks, Ian. So the word is consistency, really, isn't it? Yeah.
Yes, definitely.
Good point. Mark.
Touching on the LiDAR stuff and everything, the cowboys coming at the entry level at the cheap end and cause havoc there. That was one of the reasons. Going forward, I think I'm going to still be aiming at 40mm accuracy all the time, because that's what I need. However, what I'm looking for is the way of simplifying the process from when I've checked my control to getting the data back. Not the aircraft now, the time cycle of my data coming back. That's what I need to look at, and the consistency of when the data comes back.
Yeah, that word consistency keeps coming up, doesn't it? Yeah, that's where we are. Andy. Thanks, Mark.
It almost lends itself to a follow-on report, looking at more detail in the process and software, and standardization on software settings more than hardware. So the data capture is only a very small part. You can manipulate that data so much in any of the software packages, cloud services that are available. You could take a high resolution imagery and really downgrade it to produce poor results, and vice versa as well. Enough images from a poor resolution, you can improve your data. So it was a variable not taken into consideration on this report, but putting the same data through the same software packages, the same settings, and analysing or standardising from that point of view as well.
Yeah, I think it's a good point. I think we learned a lot of lessons from this, almost what we missed out as well as we what put in, you know, in terms of things. So I think that's a very good point, Andy. James, last but not.
Yeah, going last, I'm just trying to think of how to sum up on all of this. So I think we are in a transitional period. I think there are lots of partially answered questions, and I'd say that, you know, what we've concluded is it's very difficult to be definitive. The way forward is more information. So perhaps no individual study will give you a full answer, but I think lending weight to that body of evidence, that body of experience, has to build up in the industry, and obviously COMIT, you know, represents a part of that. You know, ultimately, for all I was saying about we don't expect everyone to become survey experts, this is a transformational technology of sorts. You know, when we introduced, you know, GIS and total stations and that kind of measurements into all of, you know, these construction industries and asset management industries and so on, ultimately, sooner or later, every single one of them had to have some reliable or usually some in-house expertise that they call upon to act on their behalf to know what they are doing. And I think this is a similar example. So again, that body of evidence simply supports that transitional journey and allows that transfer of knowledge and upskilling for all of the relevant people.
Great, James. Well, it just remains for me to say thank you very much all for coming on. Ian, Mark, Andy, James, great panel as always. Thank you very much. Hopefully we can take it to the next stage. I think we got some great stuff from the attendees. Again, I'd like to reiterate my thanks to all those drone operators and companies which participated on the test day. Like I say, they gave their time freely, and that's just it's very humbling to be part of this group. And I want to say, you know, I really do genuinely mean it. Thank you very much. It's great to be a part of it, and you know, you drive things forward. For the people that are attending, thank you very much for tuning in. Please do contact us. Please do talk to us. Please do get involved in the community. Without you, we can't take it forward. We can't break down these barriers, and we can't get drones to be a standard tool that we want it to be, helping with productivity, cost saving, and ultimately safety. So I think I'm thanked out really, and I'll hand over to Stuart. Mark, did you want to say something?
When will the report and the presentation that we've just seen be made public?
Yeah, I wanted to.
I can answer that, Mark. As soon as it's downloaded. So thanks, Tony, and thanks everybody for participating this afternoon. Fantastic session. I think this will be sought after. I want to thank the sponsors, so Virgin Media 2 and Snugs, all our webinars. I also want to say past recordings are available on the website. As soon as this one's downloaded, I'll share it. Follow us through the social media. There's a couple of addresses on there. Please do reach out. And the other thing I want to do as well is I just want to mention our upcoming webinars. We've got a rail one that's next Wednesday, interoperability in rail. There's some QR codes there, so if you've got your QR codes at the ready, just scan those. We've got a fantastic one next Friday, week Friday that is, and that's a safety product. Sorry, it's a safety project, starting in the same way that Commit to Drone started, and it's entitled The Match Made in Heaven. It's all about how technology can help move safety standing to the next level. And then, of course, we still have Fran on the call. Thanks, Fran, for stepping into the position once again. We've been doing this for years. Toys for Techies, and it's a Christmas special. I'm promised a few extras this time, Fran. One of which I believe is the challenge that I've put your way, which is for the fly drone or the drone fly, whichever one it is. The one that we saw in SEAL Team 6. So I'm looking forward to seeing that, Fran. But I'd like to say again, thanks very much for everybody participating, and Tony, brilliant job. So
just to say about that 9th December one, Stuart, if you're wondering what to get for Christmas, tune in for that one, because Fran always comes.
You'll have a lot of surprises.
Yeah, there's always a surprise.
We're looking
It's
forward
always
to
a
it.
challenge.
Looking forward to it.
If you're thinking of Christmas presents for me, tune into that one. Thank you very much.
Something for everybody.
Cheers, everyone.
Thank you,
Bye.
everybody. Thank you. Have a good day.
Thank you all.
Bye-bye. Bye-bye.